Good morning, my dear students. I hope this video finds you very well and you and your family healthy and happy. Congratulations on completing the Learning Off Campus week number 2 last week. We are now immersed into week number 3 of Learning Off Campus. On yesterday's Canvas post, I said that there's going to be an online classroom component that will be starting today. I apologize. I was a bit mistaken. I jumped the gun in announcing that. It was originally scheduled for today, but due to technical difficulties that the school has been facing, that will be starting. It just won't be today, but we are going to have that. We are going to have a live online classroom component for not just math, for all your classes. All the teachers are going to do it. It's going to be great. It's just not starting today. We wanted it to, but unfortunately it's not. That will be coming near the end of the week or possibly the beginning of next. Information will be sent out from the school detailing all that you need to know regarding that. So be on the lookout for that type of email. What websites we'll be using, your username, password, all that fun stuff. That'll all be forthcoming from the school, all right? Okay, so until then, we're going to continue on with these videos being posted and an Alex assignment coming your way. Last week, we talked of the first of several properties of exponents, and the first one we talked about was the product of powers property. Now, there's two more product properties that we're going to talk about right here in this video, okay? But let's remind ourselves what that product of powers property is. Basically, if you wanted to simplify, say, y to the 228 times y to the 153rd, nobody in their right mind would want to write out 228 y's and then another 153 y's. At least I hope you don't want to do that. And then count out 1, 2, 3, 4, 5, count out all the y's to know a grand total. No, all you have to do is take 228, the exponent, 153, and add them together, and your base stays as y, and your exponent would be 381. And we saw that this really makes sense because if you have 228 y's strung together through multiplication, and then you added another 153 y's strung together through multiplication, and you counted up all of them, you'd have 381 y's all multiplied together. Well, a much better way of saying y times y times y times y times y times y 381 times is simply saying y to the 381st. So this is the first of several properties of exponents. This product of powers property says a to the m times a to the m is equal to a to the m plus n. In other words, when multiplying powers, you need to add the exponents. We're going to learn the other two today. The power of a power property and the power of a product property. Now, as you can see, these names are kind of insane. They sound so similar. Do not spend your time memorizing the names of these properties. No. I need you to know how to use these properties. But memorizing the names is just a colossal waste of time. Because look at these names. Product of powers, that's the one we know. Power of a power, power of a product. And then you really want to get weird? Look at these last two. We'll learn those in our next video. Quotient of powers, power of a quotient. How is that any different, right? I'll show you how they are different. But the names are just so crazy similar. So don't spend time remembering these names, but do spend your time knowing how to use these properties. And so the next two properties, the next two product exponent properties, you've got all these links right here to help you practice. You're welcome to use them, of course, to your heart's content. The next two are the power of a power and power of a product property. Lots of P's there, lots of alliteration. So let's get into it. Let's do the power of a power product. Okay, now, once again, what if you raised a power to another power? Yes, you can do that in mathematics. It happens quite often. In other words, what's x to the second to the third? Well, let's figure out how we can simplify this by first exploding it out like we did last time. And then we'll see if exploding it out is really the best way to go, because maybe there's a quicker way to get there. Let's find out. Remember, mathematics is good pattern recognition, so let's look for a pattern here. We've got x to the second to the third power. Okay, so now with this outermost exponent of 3, we know the entire base is not just x, it's x to the second power. In other words, we're multiplying 3 x to the second powers together, because that's what this exponent of 3 is telling us. Okay, but each of these individual x to the second powers are in their own right an x times x, as we know. So I can explode them each out once again. Each x squared is nothing more than x times x. And don't forget, we're still kind of multiplying between all of them. So now what we have here, and keep in mind these are all technically raised to the first power now, aren't they? We have, after exploding it out, not once but twice, in other words, all the way till we can't explode it out anymore, we got x times x times x times x times x times x. In other words, if I'm multiplying 1, 2, 3, 4, 5, 6 x's together, what's a much better way of saying that, writing that? Well, how many x's do we have? 6 of them, right? So this is x to the 6th power. Yeah, x to the 6th power. Let me write that a little better. X to the 6th power. There we go. And it also makes sense, too, if we go back to that previous property. 1 plus 1 plus 1 plus 1 plus 1 plus 1 is 6. Okay. So now, guys, start thinking. Is there a way that we could have kind of bypassed all of that and then just jumped right from x squared to the 3rd to go right to x to the 6th? I think some of you are seeing it already. Look to the exponents. Is there a way we can use a 2 and a 3 to somehow get a 6? I mean, is there a way that we can use a 2 and a 3 and somehow get a 6 that we've known for many years now? Think of the most simple way to use a 2 and a 3 to get to the 6. If you said multiplication, that's just 2 times 3 does equal 6. So now this time, we were not adding the exponents because we know 2 plus 3 is not 6. We know 2 plus 3 is 5. No, we were multiplying the exponents. So a power to a power, we seem that we multiply these exponents. Okay, well, let's see if that's consistent or if that's just exclusive to x squared, x to the 6th. Here, let's do our next one. Y to the oh man, I have to write 9 y's? Okay. Y to the 9th to the 4th. Okay, well, this outermost exponent, that means that there's 4 y to the 9ths. So I got y to the 9th times another y to the 9th times a third y to the 9th times a fourth and final y to the 9th. But as we all know, I did that again. But as we all know, each one of these y to the 9ths, if I were to explode it out again, is technically y times y times y times y. Okay, that's 4, 5, 6, 7, 8, 9. Whew. Okay, well that was just 1 y to the 9th. I need to explode out the other 3, so I'm going to go ahead and do that. With the magic of editing. And you can see each of these y to the 9ths is 9 of these y's. Go ahead and count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah. And then don't forget also that if we were to, because this is exponents and powers, we're multiplying still between all of those. Alright, so here we've exploded it out twice. We first exploded out y to the 4th, y to the 9th to the 4th, and then each of those y to the 9ths got exploded out. Alright, so if I were to just count 1, 2, 3, 4, 5, how many 9s would I be saying if I did y times 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 y, all those y's multiplied together? How many y's do I have in total here? Well, you can count them out, sure. I wrote them out. But did you just instantly jump to, hey, Mr. Ripes, there's 36 y's right there? Because if you did, nice job. Okay, once again, is there a way I can bypass doing all of this? Because imagine if that was y to the 900th and y to the 421st. Nobody wants to write out those y's, all those y's. Can I just go from here to here? Well, what did we see earlier? We saw that if we took the exponents and multiplied, we got x to the 6th. Well, is that the same thing happening here? 9 times 4 is 36. Boom! Nice! Well, that's a time saver if there ever was one. Nobody wants to write out a bunch of x's and y's multiple times. Even like 36 y's was kind of a tiring task. You see, what you're seeing here, folks, is the next property. Instead, we could simply, as you just said, as we just saw, multiply the exponents. The power of a power property is just that. If you have a to the m, and that thing is raised to the n, well, that's a to the m times n. In other words, when raising a power to a power, multiply the exponents. Yeah. Before we were adding them, now we're multiplying them. Let's see a few examples here. 2 to the 3rd to the 4th. Well, yes, you could write out a bunch of 2's, or you could just say, oh, what's 3 times 4? Well, that's 2 to the, say it, folks, 12th power. Nice job, 3 times 4. A to the 2nd to the 10th. A to the, 20th. These are the 20th, that's right. And go ahead and explode these out like we were doing before if you'd like. But I'm saying with this property here, this power of a power property, you don't have to if you know how to use it, which is what we're using. Folks, negative exponents also exist. We're going to learn about those in the upcoming video starting next week. But look, using this power of power property, we know that x to the negative third, yes, that is a thing, to the negative second, and yes, that is a thing, would be x to the positive 6, positive, negative, times a negative is a positive, very good. Now, if the base is negative, big deal. The base stays the same as negative 4. But we got to take the exponent, 5, 9. So negative 4 to the 5th, to the 9th. 5 times 9, 45. Boom. We got him. You see, we were able to use this power of a power property to simplify all of these numbers, all of these expressions. Now, 2 to the 12th, just leave it as 2 to the 12th. You don't have to multiply 2 times 2 times 2 times 2 times 2 times 12 times. No, and don't even put in your calculator. It's a large number that you don't have to write out. No. Leave your answer as a base with an exponent. Same with this negative 4 to the 45th power. That's a pretty small negative number. Well, I should say pretty long negative number. Yes, it's small because it's negative, but it's also very, very long. Let's just leave it as negative 4 to the 45th power. So please understand that you are more than welcome to leave your answer as a base and an exponent. In other words, a power. Now, there's one thing, gotta say, have to say, because it's so easy to get these first two properties mixed up because they're awfully similar, okay? So let's just get out in front of it right now. There's a difference between the first product of powers property we learned and the power of a power property that we learned. If you have x to the second times x to the third, that's x to the 2 plus 3 power. You're adding the exponents. That's x to the 5th. But if it's x to the second to the third power, that's x to the 2 times 3. That's x to the 6th. You see? One of them you're adding the exponents, the other you're multiplying. How would you know the difference? When you're multiplying powers, you add the exponents. And when it puts a power to a power, you multiply the exponents. It's going to take a little bit of time to get used to that, okay? Which is why we're practicing this. And we'll practice it for a few days. But once you kind of get the hang of it, you'll see it. Power to a power, multiply. Power times a power, add them. Okay? All right, good. Let's look at our next product property of exponents, our third of 3 product properties. Now, there are more, but all we have to learn are these 3 for our purposes. This one's called the power of a product property, and I give it a nickname too, which I'll fill in just a moment. Here, let's look at a b to the third, which we know is a times b to the third. Okay, well, the base is ab, so that's ab times ab, isn't it? And we know that ab means a times b, yes? So I could kind of like separate the a's and the b's a little bit more, so I can kind of see what's going on here. Keep in mind I'm still multiplying between all of them. Now, one thing that we also know, that we've known for many, many years, is that you can multiply in any order you want. Remember, that's called the associative property of multiplication. So what if we were to kind of take these a's and b's and rearrange them so that we have a's together and b's together? In other words, I could say a, because I got 1, 2, 3 a's. And I could say b times b, because I got 1, 2, 3 b's. And I can multiply those together still, right? Because it's all multiplication. Well, folks, what's a better way of saying a times a times a? I'd say that's a to the third. And what's a better way of saying b times b times b? Yeah, b to the third. And I'm still multiplying between them. And that one thing I do to like finish this off is I could shove that a to the third times b to the third together and just say a cubed, b cubed. And then, heck, I'd be done. That's it. That's it. All right, so let's think about this. I started off with ab to the third. ab was in parentheses. Thus, ab was the entire base, okay? A wasn't the only base. B wasn't the only base. AB was the base because it's contained in parentheses. Is there a way I could have gone right from there, the start to the end, without having to do all that, without having to explode it out, bypass all of it? You might be seeing it. I call this property the mini distributive property. Now, if there's one thing we all are familiar with, it's the distributive property. Remember, I've been drilling that into your mind since 7th grade, or at least trying to. Well, this one I consider the mini distributive property. Now, this is just a nickname that I give it. This is not a formal name. You won't find this probably in any textbooks, but I call this the mini distributive property because really all what you need to do to get this property done is you take this exponent and you distribute it to the a and the b. In other words, all the pieces of the base. You distribute that exponent 3 to all the pieces of the base, the pieces here being an a and a b. And because I call it the mini distributive property, because that 3, that exponent, that's a little tiny number in the right corner, it stays as an exponent. It stays nice and small, it stays as an exponent, but it's an exponent to all the pieces of your base. Yeah, the mini distributive property, ab to the m, distribute the m, a to the m times b to the m. Yeah, that's the power of product property. All right, nice. Let's use it. Here we have 4 different examples. All right, I'm going to do the first one for you. I'll do the first 2 for you, then you'll try the next 3. Next 2. All right, so let's see here. Xy to the 6th. Well, yeah, I could explode it out if I wanted to, but that's a lot of xy's. I'm just going to go ahead and distribute it. This 6 goes to the x and the y. So that's x to the 6th, y to the 6th. I'm done. That was it. That was a great property to use. Got the answer nice and quick. Yeah, see, if you know these properties, folks, really think of these as shortcuts. That's really all they're doing. But they're properties, right? And a property in mathematics is a rule to be followed. And if you know this rule, you could save yourself a lot of time. Here's the next one. Now notice in this next one, in the parentheses are not just x and y, but also a 9. Careful. Easy room for mistake. The 2 gets distributed to the 9, the x, and the y. All 3 pieces of the base. 9 squared, x squared, y squared, and 9 squared, I'm just going to go right ahead and say 81, right? Because 9 times 9, x squared has got to stay as x squared, and y squared stays as y squared. Done. See, I squared 9xy, which makes sense, because isn't that like saying 9xy times 9xy? Well, 9 times 9 is 81, x times x is x squared, and y times y is y squared. Yeah, that's really what we're doing. The next one I want you to try, the next 2. Pause the video now, try them on your own. When you're ready, unpause it, the answers will be revealed. Did you get that and that? For the third one, I got negative 64, x to the 3rd. And for the fourth and final one, I got 81, n to the 4th. Keep something in mind, folks. When you distribute that 3, the base here is negative 4, not positive 4, negative 4. And negative 4 times negative 4 times a third and final negative 4, that's 3 negatives you're multiplying together, which means your final answer is going to be a negative, in this case a negative 64. And then x to the 3rd stays as x to the 3rd. We don't know what x is. We don't care what x is. We don't want to know what x is. We'll solve for that later, all right? But let's get these properties down. Same with this one. The base is still negative 3. And negative 3 to the 4th power is like saying negative 3 times negative 3 times negative 3 times negative 3. So now we have 4 negatives multiplied together, an even number of negatives. So therefore, they cancel each other out, all of them. And you get positive 81. And then n to the 4th stays as n to the 4th. And there you go, folks. We're using our 3 product properties. Okay, nice job. I believe you are ready. Thank you, SpongeBob. Let's take all 3 of these properties, the product of powers property, power of a power property, and the power of a product property. Again, do not remember these names, okay? You heard me just read off those names. Tell me those didn't all sound the exact same name. They're all 3 different properties, all similar sounding names. Let's take all 3 of them. Let's put them into a blender. Let's add some ice, maybe a banana or 2. Hit frappe. It spins around, it makes that noise that a blender does. You know the sound I'm talking about. You're hearing in your head right now. And let's try to simplify these types of problems here that make use of all 3 of those properties. That's right. You see, that's what this unit's about. It's not about using individual properties one at a time. I mean, that's part of it. But the major part of it is, can you use these properties when they're mixed together? Let's do it. I'm going to do this first 2 with you. Then, the tube down here, you're going to try on your own. And then, of course, pause the video. The answer will be revealed. We've been doing this. All right, so let's do these first 2. Let's see. Here's what I recommend, okay? Listen to what I'm about to say. I want you to keep it in mind. I always highly recommend that you start with that mini distributive property. Let's distribute that little 2 to the big number 2, the base 2, and to the x to the third. Okay, now careful, this is the first time we're seeing something like this. Well, the 2 gets a little 2 exponent, and the x to the third gets a 2 as an exponent. Notice I put parentheses around the x to the third to indicate that this is x to the third to the second power. Look, if I don't put the parentheses around it, it looks like I'm talking about x to the 32nd power, which is not what I'm talking about. I'm talking about x to the third to the second power. And then that x, that's 2 right here, does not get distributed to the 4, because that 2, its base is 2 and x to the third power. Okay, so the x to the fourth just kind of stands alone. All right, so we use the mini distributive property. Now, let's see what we can simplify. We've got 1, 2, 3 different pieces right here. We've got 2 to the second power. Now again, take this in pieces. This whole unit is about taking it piece by individual piece. Not rushing into it and trying to solve the whole thing at once. No, 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 no. Take it piece by piece. I cannot stress that enough. You will hear me say that often in our videos and on these online classes, okay? Piece for 1, 2 squared. Well, we know that's 4. Piece number 2, x to the third to the second. That's x to the, well, that's a power to a power, so we're multiplying. That's x to the 6th. We're not adding them, multiplying. It's power to a power. And then the x to the 4th. We haven't done anything with it yet. We're not done. There's one more thing we can do with this. We could take the 6 and the 4, and we can now add them together. In other words, ignore that 4, and you got x to the 6 times x to the 4. Well, that was our first product property. So that's x to the 10th. We're adding them together this time. Now we're done. Yeah, 4x to the 10th. Piece by piece, all right? We looked at it small piece by small piece. If you go too fast or if you rush, you're going to make mistakes, which is something we're trying to avoid. Let's do the second one. Let's see, we got a 10 here. Nothing can really be done with that. We got m to the 4th. Nothing really can be done with that. But look at this over here. We got 2m cubed, and that whole thing is raised to the 6th power. So like I said, I'm going to go ahead and just use that mini distributive property first. Notice the 6 is not being distributed to the 10 or the m to the 4th because 6 is the exponent with the base 2m cubed. Notice the parentheses tell you what the 6 gets distributed to. So 10 is just the way it is. M to the 4th is just the way it is. 2 to the 6th power. M to the 3rd to the 6th power, right? Because I'm distributing that 6 to the 3. So let's see here. Well, a 10 I can't do anything with yet. The m to the 4th, nothing yet. 2 to the 6th power. That is, that's quite a number there. That's 64. M to the 3rd to the 6th. Do I add 6 and 3, or do I multiply them? If you said multiply, nice job, you got it. But we're not done, folks. I mean, technically, aren't we looking at this is 10 times m to the 4th times 64 times m to the 18th? Couldn't I rearrange this so that I have a 10 and a 64 next to each other, and the m to the 4th and the m to the 18th next to each other? Now let's simplify. 10 times 64, 640, times m to the, what do I do with the 4 and the 18? Do I multiply them? Do I add them? I add them this time, because it's power times a power. There you go, so it's m to the 22nd. So this whole thing is 640 m to the 22nd power. Wow. Notice that for both of these problems, we used both. I repeat, both. No, I shouldn't say both because there's 3 of them. We used all 3 product properties of exponents, all 3 of them. Yeah, the 3 that we put into a blender. Thank you once again, SpongeBob. Good. All right. These next 2 right here, I'm going to ask you to try on your own. Pause the video now. When you're done, unpause it. See what you got. Did you get these solutions? Negative 2,304 x to the 21st, 320 c to the 13th. Now, if you did not, or if you made a slight mistake, feel free to try and correct your mistake, see what you did wrong. Notice that I showed every single step. All right, I showed all my work. Very helpful. And I took it piece by individual piece. I did not try to do too much in my head. If you need one of these walked through, feel free to reach out to me anytime today. I'm available online. Check the Canvas post for when my online availability is and using which platforms. Feel free to reach out to me. I'm happy to help you on this, on the Alex assignment, you name it. If you can correct your mistake on your own, nice job. All right, last bit here. What if we had to kind of reverse this? What if we had to find the missing exponent based on these properties? Here, let me help you out with this first one. X to the 6 times x to the question mark is equal to x to the 12th. Well, I know that because I'm multiplying a power times a power, I'm going to add the exponents. So what number do I have to add to 6 in order to get 12? Well, the question mark must clearly be another 6, because 6 plus 6 is equal to 12. All right, good. Now, here it's a slightly different one. All right, I'm still trying to get x to the 12th, but this is x to the 4th to the power. I don't know what the question mark is. Because this is a power to a power, I am multiplying the exponent. So I have to take 4, multiply it by what to get 12? Well, the question mark would therefore be 4 times, 3 is equal to 12. Good. Look at this next one. I'll try this third one, and then you'll try the next 3 on your own, and we'll end it there. This is 3 to the z, 3 times z to the power. I'll stop doing that grunt, that's weird. 3 times z to the question mark power, and the whole thing is raised to the 3rd power, so once I know this is a power to a power. Well, let's see here. If I took 3 and distributed to that bigger 3, well, 3 to the 3rd power, yeah, that is 27, so that's taken care of. But z to the question mark power to the 3 needs to get us to 18. And once again, because it's power to a power, what do I multiply 3 by in order to get 18? It says 6. Nice job. The question mark would, in fact, be 6. And you can always check your work. 3z to the, I think my solution is 6. And the whole thing is raised to the 3rd power. Let's see here. 3 cubed z to the 6th to the 3rd power. Well, 3 times 3 times 3. Yeah, that's not 9, folks. That's not 3 times 3. That's 3 times 3 times 3. That's 27. And then z to the 6th to the 3rd. 6 times 3 is 18. So I know I got it. Can you try these last 3 on your own? Find out what this question mark must be, this one must be, and this one must be. All right, pause the video now. Try it on your own. When you're done, unpause it. Let's see what the solutions are. Did you get 4, 5, and 3? I hope so. If not, look at what you did. Check your work. Check your math. Check your calculations. Let me go over one of them and see if you can correct the other 2 if you got them wrong. This last one here, it's kind of a doozy. Kind of a longer one. Notice something, guys. You don't even need to pay any attention to the 5 and the 10. Those things just kind of work themselves out if you use the right exponent. Now, look at this. I'm trying to get to a 21 here, right? A to the 21st power. But I've got an a to the 6th and a to the 5th to the some power I don't know yet. Well, if I take a to the 5th and raise it to some other power, I need to multiply. So whatever number I get from that has to be 21 after I add. I repeat, after I add 6 to it. So what number do I have to add to 6 to get 21? So 6 plus question mark should give me 21. Well, isn't the question mark, doesn't have to be 15 here? Okay, because 15 plus 6 is 21, right? But look, if this part right here has to be 15, this whole 5 to the question mark, I have to multiply 5 times something to get that 15. And the only thing I multiply 5 to get 15 is 3. So there it is. It's that kind of logic that we have to kind of use to get through these types of what's the hidden exponent problem. And if you use logic and basic computation, you can get it. But these take a little bit of practice. Okay, if you have questions on any of these problems that you've seen in this entire guided note, feel free to reach out to me online. I hope to hear from you. Hope you have a great Tuesday. And remember, like, comment, and subscribe. Click that bell for notifications. Have a great day.